Hi there.
Brian.
I'm Sasha from Coding Rooms.
And I'm Angela from Coding Rooms. And today we have a very interesting podcast all related to talking about how text-based programming really is important for kids to get started with at an earlier age than what we're currently seeing, and how it compares to block-based programming, and also obviously starting off with our product updates and then delving into kind of our thoughts related to this. So without further ado, I'm going to pass it over to you for the product updates.
Thanks, Angela. So this week, same as last week, we have a lot of new features coming out. The first one is we released into a opt-in beta our updated conferencing functionality that comes with a whole new chat environment that will be fully persistent as well now. So when you create a new classroom on Coding Rooms, you're able to select this. And over the course of this week, we'll move this into an opt-out beta. And then we will slowly begin phasing out the old conferencing view as the new conferencing functionality reaches feature parity with the old version. And with that update comes primarily a lot of much better audio-video quality, as well as overall stability across platforms. Next thing is, last week we did ship the comments functionality, so you can highlight a piece of code in any code editor on Coding Rooms, right-click and click Add a Comment, and when you type in your comment, you save it, it will immediately be reflected in real time with all the other people who are viewing that code, and then they can mouse over and read the text of your comment, and also then reply to your comment or make the fix that you'd like your students to make. So this is a non-invasive way to provide feedback without having to actually add lines in students' code, for example. And then this week we're also shipping auto grading with assignments, and then after this ships, we'll also ship a more formal assessments feature where you'll be able to use the same question database that you use for your assignments for exams. And those will be timed, whereas assignments are more like labs that are open, and there's a whole submission and feedback flow. So you can expect that to go live this week. There's also one more Python, especially Python related file operations feature that will allow students to see the files that were changed by their program after they run it. So it's a small, almost like a bug fix, if you will. So with that, I'll hand it over to you, Angela, to continue.
Yeah, well, I'm personally excited about the comments because I think that's going to be very efficient for all teachers and as well as students when they're collaborating, and it makes it faster to see exactly what section of the code you're talking about, right? So without further ado on the topic of products, but just more so talking about now our main topic, which is text-based programming. So before we delve into text-based programming, let's kind of discuss just different actual hardware devices that kids are using nowadays in the classroom, because based on the hardware there could be certain limitations to even achieving text-based programming, right? So we know that students like to use Chromebooks or iPads, especially in elementary school when they're starting to digitize their curriculums, and just certain things about them, like such as the fact that certain lack of the ability to compile certain languages is one, and second of all is also the interface itself. So if you have any thoughts on just like from a hardware perspective before we delve into more of the technicalities of learning coding.
So devices for every student, or iPad for each student, or Chromebook for each student is really great because it overall advances the penetration of technology in education, so more students have access to these tools. But a big drawback is that generally these tools are not meant for creators, right? They're meant for consumers. And what I mean by that is they're not really set up for you to be a creator of software. They're meant purely as a consumer of software. iPad is not meant for writing code, And so writing code on an iPad is very challenging, not only just from a pure technical standpoint, because basically everything has to be done in an app or in the browser, which basically precludes you from using your typical development environment. It's like IntelliJ, for example, that we use at coding rooms. There's really no way for you to run that on a Chromebook or on an iPad. So it leaves students to use subpar technologies, I would say, right? I mean, ultimately...
Sorry, my phone just dropped.
Yeah, I'm having
Apologies.
some technical issues in the live stream. So it leads you to use...
Sorry about that.
It leads you to use, technologies that are not industry standard, let's say, and that is a challenge also for teaching, because
I'm sorry, just let me laugh it out.
Yeah.
Apologies. My phone's an iPhone 11 Pro, which is arguably the largest, heaviest phone that Apple's made. Maybe iPhone 12.
Well, this is the first time in
more
all
heavy.
of our live streams that
Well, at least you know that we're actually live on these, so
Yeah.
apologies. Okay, let's get back into talking about technology.
So the big drawback with devices like this is that they make it challenging to really create meaningful output. They're not necessarily bad for learning, right? So this is kind of where we have to consider all of the different solutions that exist, and they are good for block-based programming, for example, and they are getting to a better place when it comes to text-based programming. But this is a big debate, right? I mean, if I can't run any custom software on my school computer, I either have to become a hacker or I have to give up, right?
Yeah. Well, it's true. I think I really like your point about it being more from a consumer perspective, because I mean, it is great, right? Like applications like Swift Playground, it visually appealing to kids. Like an iPad interface especially is very engaging. It's very, low learning curve. I think I've seen kids 3 years old or even 2 years old just playing around with touching an iPad. So it does get, younger kids a lot more excited about at least learning the logic behind programming. And with block-based programming, it's a good way to at least be introduced to certain ways of thinking and the logic. But I think what we're trying to kind of delve into is that we do see a lack of just more creators in terms of getting introduced to programming in this way.
So the first time that I heard about block-based programming, because I kind of missed the wave for it. So when I was in school, I think block-based block-based programming has existed for a long time, right? It's just
I mean, I used Scratch probably 6-7 years ago. Oh, I don't know, longer than that. 10 years
by a long
ago.
time, I mean block-based programming has existed in the so-called, not in the education space necessarily, in the no-code application development world, for decades, right?
Yeah.
I mean, it's not a new concept. Now, there's a sort of history to no-code development or to browser, or like this block-based programming paradigm. And the problem is that you either at some point you have to give up on blocks where you write custom code, because you run into something that the blocks don't support, or you have to be really comfortable with the limitations imposed on you by block programming, namely productivity and flexibility. So with block-based programming, dragging around code blocks might seem really easy at first, but very, very, very quickly you realize that it's super slow.
Yeah.
Because if I want to, for example, I type 100 words per minute, let's say. So if I want to quickly knock out a whole file with a class and whatever, generate some code and then fill in some functions, I'm limited by my ability to think, not by my ability to type. Whereas if I'm dragging around block-based code snippets, for example, I'm actually searching through the list of blocks. I need to find the right block, move it over, place it into my code, customize all the different parameters, click around into clunky interface. Now all of a sudden you're limited by your tooling. And in the software world, so whenever you start fighting your tooling, there's only two possible options. Either the tooling's bad or you're doing it wrong. And with block-based programming, you kind of end up, most often you end up with the tooling is bad, right?
Yeah.
It doesn't support your use case.
Yeah, and I really think it's also real world applications, right? Because at a certain point, at least industry level, you are going to have to feel comfortable to go into text-based programming at some point.
So if we can talk about because we haven't talked about this yet, which is the educational value of of block-based programming. The primary sort of most cited benefit, if I had to summarize it like this, is that it decreases the initial frustration of learning how to code, right? You can get to Hello World faster. You can get to Hello World +1, sort of that immediate next step in an easier way. You can do it with younger kids. It's not quite as complicated, and you don't get nasty syntax errors, right? If I want to write a Hello World in Java, it's actually relatively complicated, especially if I'm typing on an iPad and I don't really understand certain nuances, such as the fact that a capital S, when I type system, is completely different from a lowercase s, and one of those will give you a really weird error that would be completely unintelligible for someone who's writing code for the first time, versus the other one, which is the correct solution. So by virtue of breaking down these barriers, you're able to get people, quote unquote, excited about coding, even though it's not coding in the traditional sense.
But it's definitely like making it more like a consumable puzzle, right? Like it's like they're more thinking of it like, hey, I'm trying to solve a puzzle. Like it's more, not necessarily to say more like a game, but like it's more user friendly, and it's less like you're less getting caught up on the small.
So this is where I actually take issue with the whole thing, right?
Yeah.
Because by saying that this is coding, first of all, you're kind of lying, let's say, right? I mean, you're really sort of further obfuscating the true nature of what programming is, as sort of obfuscated as it already is in our daily life, right? People don't see code on a daily basis unless you're a developer,
or think like that too, even.
Yeah. Well, that's another interesting whole nother topic, which is, could this help bring people into a computational thinking mindset, make them more comfortable with logical thinking? I mean, personally, in my sort of super limited experience with block-based programming, and never really having personally taught meaningful numbers of people block-based programming, it does seem like that there is that certain limited value, right, in reducing the learning curve. But the big question is, am I just delaying the fate of a lot of programming students, which is the fact that they will drop out.
Yeah, at a certain point they're gonna have to face the truth. Because the thing is, for me, unlike you, I actually have done block-based programming. Actually, in middle school, I used Scratch, which is a very popular way to get kids, excited about programming. And I would say I did face that. I think it's more about also how the teacher frames it. I mean, obviously with every case, it depends, right? Like, how are you teaching or using this tool to further engage your students in being interested in programming? I think for me, the lack that I saw in my class was that I didn't really know what the end goal was. We did it as a fun activity for a few weeks, and the real purpose wasn't told. Wasn't
that's another interesting
talked about
issue with block-based programming, right? Which is since it's not really a tool for creators, it's more like a game, right?
Yeah.
And they're usually bad games, because when I was in middle school...
Well, I remember it was more about going through a maze, like turn 90 degrees left, and then, you know.
Exactly. Yeah. Right? I mean, I think I was playing Call of Duty in middle school. I mean, or, you know, or early high school, whatever. Yeah. So, I mean, the idea of what's fun and engaging for middle school is also really high.
Yeah.
Because a lot of gaming companies have really set the bar in that area. So first of all, before we get any deeper into this, we should say that there is no real answer to this. This is purely conjecture.
No, it's definitely. I mean, I'm just sharing my personal experience, and I would say like 7-8 years ago when I first got introduced to Scratch and we were doing an ICT class, I didn't know what the purpose was. The teacher was like, "Hey, do this," and I also even created a game in Flash, and I was like, looking back at it, I was never told what the purpose was or what the applications are.
Well, that could be, right,
instructor style or however the curriculum is framed.
It's not an inherent issue of... You could say the same thing about Java. I mean, what's the purpose of writing a calculator with Java Swing, right?
Yeah.
That's also a little bit... I guess it's easier to see what I could do with that. Again, it's also another thing of... So when I learned programming, which is now about sort of in a meaningful way, which is coming up on 10 years ago, I, was using things like Java, AWT, and the C++ libraries were just building desktop applications. And the neat thing was I used a lot of apps that I knew were written in that way, right? So all of a sudden it's like, hey, I'm using that cool app that I use, I'm using the same exact tools and I can build that app. Nowadays is super tough, because if I want to build coding rooms, for example, I have to use a ridiculous number of languages, frameworks, tools. It's crazy. I can no longer just sort of, and of course there are exceptions to this, but from definitely not in the same way that it used to be, where you can just open up basically one development environment, run it on your computer, and with like one sort of run command, immediately have my full app running. Now, if I'm talking about doing Android development nowadays, that's gigabytes of setup, right? To do just open up Hello World on an Android app.
Wait, why is that though? Is it the behind the scenes infrastructure? Is it how advanced, why is that?
I don't know. So this is particularly sort of pervasive, I would say. Actually, I think it's really negative in the front end side of things. So developing back end applications is still the same, right? Nothing has really changed. You've got a database if you want it, database if you need it, and then you can build your logic, right? The problem is that's super detached from your typical user experience, right? Very few people interact with command line applications anymore, all this type of stuff. So, or just building algorithms for the fun of it, right? So you're in a very isolated world, and the moment that you want to leave that, you have to learn lots and lots of new stuff. Unless you want to build disgusting looking Java applications that look like...
Are you saying it's just purely because aesthetics have gone up? Like, it's just the look and feel and the user experience and all that kind of factors all into this sort of
I think,
thinking?
This is something I've been thinking about, sort of completely unrelated to the discussion, actually.
Yeah, sorry, we're kind of going on a tangent here, but we'll draw it back in it.
Yeah, I'm sure it's meaningful. So, actually, I was thinking about this a lot lately, about actually web development frameworks that are terribly complicated, right? I mean, typically just to set up a basic Hello World application is thousands of files, right? Because if you're going to use some framework, that framework will pull in dependencies, and you have to install the dependencies. And all of a sudden, you end up with this huge project that does nothing, and it breaks. Because if you have thousands of dependencies, the chance that you know,
One
if you
of them, yeah.
one of them will break or not work on your computer, is all of a sudden super high, even though, you know, if I only have one dependency, it might be really low. So that's something that I think is a barrier that didn't exist in the same way. It's not like in order to do something I had to do this, right? In order to build something that looks good. I mean, nowadays, to really build anything meaningful, I think it requires just an insane amount of knowledge, tools, and experience.
So drawing it back, that's why, you know, text-based programming is just that much more important, because the threshold, as you were saying before, is a lot higher just to get into programming something meaningful, if we put it that way.
So there are sort of like there's sort of two schools of thought with the block-based programming, right? One is that it's an on-ramp into text-based programming for people who maybe will study CS, become developers, or will use programming in a meaningful way in some other capacity. That's one segment. The other segment is, hey, maybe people shouldn't learn text-based programming. Maybe there's enough value purely in computational thinking. And at least, let's say, at this age group where text-based programming is more common, block-based programming is more common, whether or not that's valuable on its own. Valuable on its own, I don't know, honestly. That's not an area that I've done too much research into, or personally really am well acquainted with. The other side, the former point that I mentioned, is sort of more concerning, because there's, and this is not anything that I can quote right now off the top of my head, but I remember when I was looking into this, a number of years ago, the data on people going from block-based programming directly into text-based programming, using that as an on-ramp, the success rate was not terribly good. Let's put it that way, right? I mean, it doesn't. The biggest problem is that, in my opinion, learning programming involves learning syntax, and learning syntax is just one of the fundamental necessities of learning programming, right? And that is a lot of what precludes people from doing anything meaningful, is because they can't get past that initial activation energy required to do something. The thesis with block-based programming is that we can get you to a place where the activation energy, let's say, required to get going in a meaningful way with text-based programming is lower, because I already understand logic, so now I only have to understand syntax. I personally don't see that working in a meaningful way.
I mean, like, I'm just, like, as you were talking about this, kind of drawing an analogy, right? Like, it's almost like the syntax is the grammar. Like, if you're talking a certain language, right?
Exactly right.
You can learn the grammar first and learn it right, and then, your grammar just ends up improving as you go. Or you can learn broken English first, and then somehow try to backtrack and learn that grammar to make it better. So it's really about, like, how much do you want to get out of, the value of learning programming and computational thinking, how much value you want to get out of it, right?
Exactly. I mean, it's worth mentioning that both of these approaches have their place. That there's no like cancel a block-based programming incentive, right? Especially not at the lower age groups. I think it's challenging to say. We have to take the approach that something's better than nothing, and if this is what we can do at that age group, by all means, let's do it. And how can we improve that to then make it a better on-ramp into text-based programming? I'm all for it. But in terms of just general public, more from kind of like from a scientific perspective, whether or not that has a clear impact on your ability or likelihood to have a easier transition into text-based programming, or so-called like real programming, I think is sparse at best. Right? And that's ultimately sort of what we're talking about. It's like the real question here is not if I'm 12 not if I'm like 8, I guess, and I want to learn like some coding, right? Because it's almost kind of like a done deal. You kind of want to start with some cool game block-based stuff, and then hopefully that will move you into something and at least get your interest going.
But you can't rely on it, right? Like you can't say like, hey, I'm great at block-based programming, I want to become a software engineer.
So this is like the sort of Dunning-Kruger effect, right? I mean, ultimately, and this again is something that's not super well studied with block-based programming. There's really just a lack of real meaningful data on this, whether or not that plays a role. But one more interesting piece actually is and by the way, that's true for Codecademy. That it could also be said for a lot of text-based programming intros that are like, hey, copy paste from the left side to the right side, and woo, it ran. It's like those also give you that false sense of knowing. But sort of the more interesting piece, I suppose, with the block-based programming would be how to actually increase that conversion or applicability at higher ages, right? Because at higher ages you still have the same crazy dropout rates, right? And the people who hate programming, can that have a meaningful impact by sort of softening the initial blow? And then one other point that's sort of worth mentioning is rarely do we talk about the people who are actually off-put by blocks, who think blocks are a joke and are not excited by blocks because they want to be hackers or they want to want to do real coding. I mean, I can say probably I am more of that personality type. I think it's generally sort of more of a male like personality type of, I want to be like into the hacking thing, and perhaps you can say maybe this is sort of also potentially a contributing factor why at some in some age groups and in some settings, I should say in a lot of settings, programming is very male dominated. Like maybe that's because there's a certain allure that generally
maybe it's just mass media being like, oh, you can be a cool hacker, like
there's something appealing.
Movies.
There's
I mean, definitely media plays a role in it too, right? I mean, these are all generalized stereotypes, but it is true. It is true that
So could block-based programming be a means to address that? Is an interesting question. But there's ultimately really no good data on this. Not, at least none that I've come across recently. And we're really left to guess on a lot of things. I will say that ultimately, I think the biggest sort of the biggest factor, regardless what you're doing, is the teacher. I mean, ultimately can't take that out of the equation. So if I'm in a class of 20, 30 people and I have a great instructor, I don't think it really matters what you're doing. I think if you have a great instructor, they will make it applicable. They will teach it in a way that makes sense for you, and they will help you work through those issues. So I think in terms of if we had to talk about what has the biggest impact, I would say by far the instruction. Because I can teach boring block-based programming, I can teach super boring and painful text-based programming. It is, a lot of that is up to how you teach it. Right? And maybe that's a good way to close on this topic.
Well, it's good discussion. It brings a lot of thought into this topic. So because we were just so engrossed in this topic, our thought of the day is also just text-based programming is fun. I definitely see the value because I've done block-based programming, and I definitely think it doesn't, at least the way I was taught, it doesn't relate at all to what I later experienced in text-based programming. I would say no relation whatsoever. It's like jumping off a cliff. It's like, oh, actually, this is where everyone else is at, well, thanks for joining us this week on our podcast, and we'll see you next week.
Thanks.
See you.
Bye-bye.
Bye.
Bye.